Hi everyone, welcome to the second of two videos going through some past exam questions on enthalpy changes, calculating enthalpy changes. So in this video we're going to do this question where we've got an enthalpy of combustion set up. So what they're doing here is they're burning some kind of alcohol in the spirit burner and they're using that to heat up the water. They'll measure the temperature change of the water and use that then to calculate the enthalpy change of combustion. So that's what they're asking us to do, calculate the enthalpy change of combustion. Okay, so the way we're going to do this is using the equation that we've seen before, Q equals mc delta T. So what is the mass here? The mass is going to be the mass of the water that we've heated up. Okay, that's the important thing. So it's the 180 grams of water. It's definitely not this. Be careful. That's how much alcohol's been burned. We want this value, the 180 grams of water. Okay. We're going to times that by the specific heat capacity of water. That's why we need the mass of the water. And we're going to times that by the temperature change. So we'll just work out the temperature change here. 75.3 minus 22.8. That's 52.5. Okay. Let's work that out. And we get 39501, and that is going to be in joules. Okay. We can tell it's in joules because of the units of the heat capacity, and we've multiplied by grams and we've multiplied by Kelvin. So now then we need to convert this into an enthalpy change. This is not the answer because it needs to be in kilojoules per mole. So we can divide it by 1000 to get 39.501 kilojoules. And now we need to divide it by the number of moles to get it into kilojoules per mole. So how are we going to work out the number of moles? So from this we are going to use the mass of the alcohol here. So we're going to do 1.54 grams divided by the MR of this, the relative formula mass of this alcohol. And that's going to give us the number of moles. So the alcohol that we've used is right back here at the top of the question, C5H12O. Okay, so we're going to need to work this out. So it's going to be 12 times 5 plus 12 for the 12 hydrogens plus 16 for the oxygen. It's 88. Okay, so we can then do this divided by 88 grams per mole. So let's have a go at that. 1.54 divided by 88 is 0.0175 moles. Okay, and now we're going to do kilojoules divided by moles to get it into kilojoules per mole. And we get 2257.2. But now we always need to be careful with how we write our answer down for these questions. These questions are always worth 4 marks, and the 4th mark is always for writing it correctly. We need to do it to the right number of significant figures. Okay, you almost always specify in these questions. So here we want this to be 2,260. I'm going to round up here. And then we need to think it's an enthalpy change, so it needs to have a sign. It needs to be either positive or negative. What happened to the temperature? Well, it's enthalpy of combustion, right? So it's always going to be exothermic. Enthalpy of combustion is always exothermic. And the temperature's gone up, so it should be minus. Okay, delta H is negative for an exothermic reaction because it's releasing energy. So the enthalpy of the chemicals goes down. And then this bit here, this is a very common question that follows on from a calculation. It says the calculated value from this experiment is different from the value obtained from a data book. Apart from heat loss, okay, so be careful with that because a number of people that I see actually writing heat loss as an answer. But something other than heat loss suggests 2 reasons why they're different. Okay, so heat loss is a big difference because when you're heating this up, you're assuming that all of the heat from here is going into the water. And it's not, as it is heating up the air, it's heating up the beaker itself, it's heating up the clamp. So heat loss is a big problem. but we need to give two answers other than that. So what other problems have we got? So this is going back to thinking about the definition for enthalpy change of combustion. Okay, for it to be enthalpy change of combustion is when 1 mole of a compound is completely combusted in oxygen. So if there is any incomplete combustion, that is going to lead to an incorrect value. Okay. And one of the other things we can say is that the value in a data book will have been done, they'd have done the experiment under standard conditions. So if we haven't done this experiment under standard conditions, we're not going to get the same answer. Okay. So those are the two answers that I would go for. Okay, let's look at one more question. So here we've got ammonium thiocyanate. It's reacting with barium hydroxide. Okay, if you say so. We're carrying out an experiment to work out the enthalpy change of the reaction. Okay, fine. They're doing some sort of thing. We've got to do the calculation again. Yeah, but this time they've split it up. Okay, so this is another one where they've split it up into sections instead of doing it all in one go. Okay, which I think is probably actually easier because it means at least it gives you that structure so you know what you're doing. So we're going to start off the same way. We're going to start with Q equals MC delta T. So the mass here is the 50 grams of water. Okay. The heat capacity here, just make sure you're reading the question. In all the other questions, the heat capacity has been 4.18, and in this question it's 4.2 for some reason. But we need to use whatever value they've given us. So they've just rounded a bit more, but make sure you use that value. Don't get clever and think you know what it is. And then the temperature change is from 21.9 to 10.9, so that's 11. I can do that in my head. So let's calculate that. 50 times 4.2 times 11. That's 2,310. But that's in joules. They want it in kilojoules. Remember when we do this, it always comes out in joules because of the units here. So in kilojoules, it's going to be 2.31. You can put a 0 on the end if you want, I suppose. Okay, now we need to calculate the number of moles. Yeah, we calculate kilojoules, don't we? Then we calculate moles, and then we do one divided by the other. Okay, so calculate the number of moles. So this is going to be the mass divided by the formula mass. So the mass of the ammonium thiocyanate was 15.22. And then we're going to need to work out the MR. Let's do this here. They haven't told us, have they? Sometimes they tell you in the question. I don't want to waste time doing it. No, they haven't told us. We have to work it out. So we're going to have 14 for the nitrogen, 4 for the 4 hydrogens. Sulfur is 32.1. Carbon is 12. And nitrogen is 14 again. So here we go. 14 plus 4 plus 32.1 plus 12 plus 14 is 76.1. So let's put that in here. And let's see what answer we're going to get. 15.22, yeah, divided by 76.1. 0.2. Nice. It's come out as a nice round number, hasn't it? We'll take that. All right. And now calculate the enthalpy change of reaction. So now we're going to do our 2.31 kilojoules divided by our 0.2 moles. And this is good. They've actually told us here, like I've been banging on about this every question. They've actually said here, make sure you put a sign in it. So that's a nice bit of a reminder. Make sure you actually do that. There's really no excuse not to do it this time. So 2.31 divided by 0.2 is 11.55 kilojoules per mole. Okay, and then we need to do this to two significant figures. So we're going to round this up to, excuse me. Yep, so we're going to round that to 12. And then we need to have a think about the sign. So let's go and have a look here. Where does it say about this? Now we're going to need to be very careful here, because this question, this is a bit sneaky. I think they would let you get away with this, but they've asked you to calculate the enthalpy change of reaction. Okay, well, the enthalpy change of reaction is, if you look, the definition for enthalpy change of reaction is the enthalpy change for the reaction in the molar quantities expressed in the equation. Okay, if you look at the equation has 2 moles of ammonium thiocyanate in it. So if we're doing it as 11.55 kilojoules per mole, we should actually times that by 2, because this equation, as it's written in the molar quantities in this equation, has 2 moles in it. So if we're doing enthalpy change of reaction, we should times this by 2. So actually, we're not going to round it to 12. We're going to times that by 2 first. And then we get 23.1. So we're going to then round that to 23, to 2 significant figures. That's a bit sneaky. I think they probably would let you get away with that, but not very happy about that question. And then we do need to think about the sign. So this was looking at the temperature change. It cooled down, didn't it? It cooled the water from 21.9 to 10.9. So if it's got colder, it must have been an endothermic reaction. It must have absorbed energy from the surroundings, which is why the surroundings got colder. So this should be plus 23. Okay.